Julie Labar. I work at Centenary University, and it is my extreme pleasure to introduce Dr. David Robinson, who is a distinguished professor at Rutgers University in the Department of Geography, as well as the New Jersey State Climatologist. Fun fact, I was doing a little bit of research on Dr. Robinson and found that he is actually the country's longest serving state climatologist, which is pretty fantastic. I like consistency. I hope everyone else enjoys that as well. Dr. Robinson's research interests run the gamut from global to local, with the underlying theme being the development of a better understanding of the climate system. As our state climatologist, he conducts research of an applied nature that focuses on the diverse weather and climate of the Garden State. He focuses on things like climate change, of course, as well as more specific weather events like drought, flooding, and my personal favorite, snow. And more importantly, probably, the impacts of weather events and climate on agriculture, transportation, public safety, and commerce. The Office of the New Jersey State Climatologist also operates one of the most spatially dense observing networks in the nation. And in addition, Dr. Robinson has actually contributed to reports published by the Intergovernmental Panel on Climate Change. In his endeavors to contribute to the discussion on climate change in the Garden State, Dave is joining us today to deliver our keynote address on climate change impacts on New Jersey's waters. And with that, Dave, I will turn it over to you.
I love talking to groups like this, engaged people. I've enjoyed the sessions I visited in the conference since yesterday afternoon. And again, I thank you for the invitation. I'm going to talk to you today about New Jersey's weather and climate, and with a bit of a spin on climate change, as you'll see later in the presentation, as well as putting a little bit of a water spin on it as well. We won't ignore temperature. It's obviously an important part of the hydrologic budget, actually, but a little bit more of a focus on water. As Julie mentioned, I come to you from the State Climate Office. The office is, as State Climatologist, I was appointed and am appointed to serve at the pleasure of the Dean of the Agricultural Experiment Station, who's also the Executive Dean of School of Environmental and Biological Sciences here at Rutgers, via a decree from Governor Byrne back in the late 70s, when land grant institutions primarily began to assume the responsibility of having state climate offices after the federal government, just with a stroke of a pen, eliminated state climate offices a few years earlier. And we've had an active office in New Jersey since the late 70s, and I've had the honor of being appointed early in my career at Rutgers back in 1991 as state climatologist. And we've actually hosted the annual meeting of the American Association of State Climatologists both in 1990 and just before I came in, and then I hosted it again in 2015 down in Cape May. So we are, as a state climate office, we're here to serve the people of the state. We're here to help people make decisions, help people understand the weather and climate of our state, but more than that, just how it affects or interacts with our everyday lives, from transportation to emergency management to agriculture to environmental protection, and on and on and on. And our credo as state climate offices is generally locals trusting locals. We interact with the Regional Climate Center up at Cornell, other climate hubs from various state and federal agencies, with the National Center for Environmental Information. Some people may know it as National Climatic Data Center, it used to be called. So we're not islands here. We all interact together. But as state climatologists, our interests are specific to our state, and we know our state, which makes it so significant. What I want to talk about today is, besides a little bit about State Climate Office and what we do for the state and for you folks, a little on the global climate system. We'll look at New Jersey's weather and climate, past, present, and future when it comes to New Jersey's climate and climate change. As I mentioned, we as a state climate office, we gather information on from all different sources. I'm going to introduce you to 3 sources initially. There's our website, and visit that for all sorts of information and monthly write-ups and so on and so forth. But we can go right on to the next slide. As I was talking about, we gather information from a large number of sources, some of it historic in nature, some of it just 5 minutes ago. This is a compilation of precipitation and temperature anomalies for the state as a whole, based on several dozen stations, National Weather Service cooperative stations, that have records back, in some cases, back well over a century. But what we do to keep people's finger on the pulse of what's going on with our weather and climate, the top figure there are precipitation departures by month for the last 12 months, November of 2019 through October of 2020, which is on the right. The green bars are above average precipitation in a given month. The red are below average. And you can see we varied over the course of this year. The beginning of 2020 was getting kind of dry until we got into this heart of the summer, and we've stayed on the wetter side since then, but not excessively wet. Not one of those months falls into the top 10 in terms of wetness in the historic past. And the historic past goes back to 1895, so that's 126 years. Now, the bottom right shows you temperatures. That tells a little different story. It tells you we've been quite warm in the past 12 months. 9 of the last 12 have been above normal, and 5 of those 12 have ranked in the top 10. The top 10, again, each of 126 when we talk about warmth. So we've had a very warm year, and we'll see later the beat goes on. We've been warm, and we're staying warm. So that's long-term data that we can provide you or direct you to if you have an interest from a limited number of stations. The next slide shows you the network that Julie mentioned. This is Rutgers, New Jersey Weather Network. It's 65 stations that we operate here in New Jersey, but we link to National Weather Service stations, a network in the Shrewsbury, Navesink area, and some roadside weather information stations from NJDOT. But we are the core of this, are our 65 stations, and they literally are situated from High Point Monument to West Cape May. Northwest Jersey has its fair share, not never enough, but some of them are getting older and we want to rehabilitate them. But every 5 minutes you can get data from these stations on temperature, precipitation, most of them incoming solar radiation, wind speed and direction, humidity, barometric pressure, some soil temperature and soil moisture, a few snow depth on the ground through a sonar system. But these are automated stations operating with solar power and accessed via cellular communication. So that's one of our networks. The next one, next slide, some of you may be a part of this program. It's our volunteer program called the Community Collaborative Rain, Hail, and Snow Network, or COCORAS for short. We're the New Jersey chapter of a national network, which also includes Canada and the Bahamas. We have about 300 active volunteers in the state. And on any given rainy day, we'll get reports from about 250 of them who go out to their rain gauge 6 to 8 a.m. in the morning, roughly. It's a standard rain gauge that is part of the program. And they then measure rain or snow and then go online and enter their data, and immediately goes into a national database that's archived at the National Climate Center. And we produce these color-filled maps. There are other maps produced by the COCORAS program. This is yesterday morning. This is the rain we had from about 7 a.m. the previous day to 7 a.m. yesterday morning. And you can see the northwest part of the state was on the half-inch rain side. Then it gradually got wetter as you went down to central Jersey. And the whole southern part of the state is in the pink and red, which means they had about 1.5 inches to upwards of 3 inches of rain in the southern part of the state. But focusing on the north today, I decided to zero in on that. But anyone can join that program by going to COCORAS.org. We have people of all ages. And it's just a wonderful citizen science program. And we invite you in. And if you don't have the interest of taking the observations, you can still visit and look at the observations that are for your particular area. I should mention these go back, this program started in 2008. Our weather network, we have some data back into the 1990s. So you can see the importance of the National Weather Service Cooperative Program, because that's the one that goes back with just daily data, but goes back again to the late 19th century. So moving on, next slide. That actually shows you North Jersey with snow depth and the equivalent, the water equivalent on the ground. And I wanted to show this because it's so important hydrologically, not just the depth of snow, but how much water is in the snow pack. And our COCORAS observers, some of them, most frankly don't, but you can see the number here who provide very important information, because the National Weather Service stations don't have this. This is valuable information for flood forecasting, for instance. You get that a couple inches of moisture locked up in that snowpack and it melts quickly in a rainstorm, and you're going to exacerbate flooding. It's also important for water management as well. So we have this unique product when it comes to snow water equivalent. Okay, going on to the next. All right, 2 slides that have to talk about the climate system, because I don't think, the next slide, please, Zach. I don't think anyone here has to debate that weather and climate are an important part of just managing our everyday lives and societal managerial issues in this day and age. But this figure from the World Economic Forum really tells the story. On the y-axis, you have impact of multiple events, all sorts of events, from, frankly, global pandemic up to a nuclear weapons of mass destruction and so on and so forth. But the impact on the y-axis goes from the bottom is low to the top high. And the lower x-axis is the likelihood of those events occurring, from low on the left to high on the right. So if you look at the top left of that figure, that is high impact but low likelihood. And that one point there is weapons of mass destruction. But then I'll draw your attention to the top right of the figure, and you can see several diamonds, green diamonds, and they correspond to climate action failure, extreme weather, biodiversity loss, and human disasters, human-made disasters, and natural disasters. That's up there in the top right. So you can see the importance of weather and climate when it comes to the short term with extremes and the long term when it comes to climate change. So the next figure just shows you what we're getting at here with the climate system. A lot of spheres involved here. They all work together in concert to generate what we know as our weather and climate, and overall our climate system. The sun does the heating. It interacts with the atmosphere, the hydrosphere, be it ocean or land-based water, the lithosphere, when it comes to mountains, valleys, volcanic eruptions and such, the biosphere, be it on land or in the oceans. And front and center there, you see human activities. I forgot the cryosphere, my favorite. As it is, I see Julie's as well, and something I do study on a global basis when I'm not wearing my state climatologist or in a professor's classroom hat. So we've got all these spheres, but again, front and center human activities, be it combustion of fossil fuels, be it agriculture or deforestation. Humans are front and center. They're a sphere of their own, interacting with all of these natural spheres. And together they make up the climate system. You can't separate them from one another. They all interact at all sorts of different time scales. It makes for fascinating learning, the opportunities for people in all dimensions of science, and these days social science, to get involved with it. It's not a cop-out, but it also explains how very, very complex it is. But we're doing a good idea, have a good idea of how things work, and we're getting a better idea of modeling these so we can look into the future. But I'm getting ahead a few slides. So the next slide. Again, we're going to talk about New Jersey's weather and climate. So on to the next. We have a great diversity of climates within our state, even though we're a relatively small state. We sit here in the middle latitudes where the prevailing winds go from west to east. But even within our great state, we have a variety of climate zones that are impacted based on altitude, latitude, whether they're covered with asphalt or forest or field. And then, of course, the proximity to water can be so influential. We're not here to talk about the coast today, so I'm not going to say much about that. But I can say I just looked at the latest temperatures before we started this, and it was 57 down along the southern coast, and it was 38 at our stations at High Point Monument and the top of the ski slopes at Mountain Creek in Vernon, our newest station in the network. So quite a variety of things. And frankly, it goes further than that. The first freeze of this fall season was on September 18th at our Walpack station. We had a few other stations up there at Sandyston, got below freezing. It has not yet gotten below freezing at several of our coastal stations. Even more remarkable than that, the last freeze last spring at Walpack was June 1st. So they only had a growing season from June 2nd to September 17th. Meanwhile, down along the coast, the last freeze last spring was March 1st, and they've not been below freezing since. So what a variety, and it shows the contrast between land and water, but in the northwest part of the state, it shows altitude. And you may say, well, hold on, Walpack's not High Point. You're right, Walpack's in the valley, a valley that traps cold air. Cold air feeds into those valleys on calm, clear nights and can be much cooler than up in the hilltops. Earlier this week, there was a morning when our Vernon station was 63 degrees and it was 29 degrees at Walpack. So what a variety we have here in the northwest part of the state. Anyway, I won't go on and on and on. Let's go on to the next slide here. We are a precipitation-rich state. Our wettest month of the year may surprise you. It's July. Our driest is February. Here the map on the lower left shows January average precipitation. And you will note that the highlands are often in the darkest greens, meaning the wettest. There's even a little bit of a rain shadow in the valley of Newton and Sussex there in the valley and ridge portion of the northwest part of the state. But the highlands tend to be the wettest. They get about a foot more rain than down along the southern coast over the course of the year, about 52 inches versus 40 inches. So we do have a precipitation-rich state, and it's distributed rather equitably in every month of the year. The good news there, of course, is we often don't get too much of it in one month. And if we happen to have a few months with a precipitation deficit, we can recoup that any adjacent month. In other words, we don't have to wait 6 months for the rainy season to come. It could come we may only have to wait 6 days when we're in a dry spell. So the next slide does admit that we can get into drought stages. We have not had a drought emergency in New Jersey since 2002. And we've had nothing like the drought of the mid-60s since the mid-60s. What you're looking at there is a black and white shot of the Delaware River bed. I call it the Delaware Stream down in Trenton. This was a multi-year drought with about 2/3 to 3/4 of normal precipitation for several consecutive years. Tree rings suggest it may have been our most severe drought in several centuries, and I certainly hope we don't face that. I often kiddingly say, I don't want the state to face that at least until I retire, because it's a lot of work when a drought comes about. There's a lot of important information has to be gathered and communicated to state officials and to the public. The next slide, though, talks about let's talk about how we get our precipitation. Sure, these mechanisms fail or they underperform to put us into drought, but there's 3 ways in which we generally get our precipitation in New Jersey. The first, on the next slide, are warm season local storms, the thunderstorms, the squall lines, and I picked out a doozy here. This is, anyone up in the Northwest remembers this in August of 2000, when upwards of certifiable 14 inches of rain. There's some anecdotal cases or measurements of 18 inches of rain fell within a half a day for the most part on a Saturday morning, which actually, it didn't just flood rivers, as you can see on the lower image. It burst dams, which you can see in the top image, and it even flooded Lake Apacon. It flooded a lake. That's how extreme this event was. And it was a localized storm. The northwest part of Sussex County had very little rain, as did most other spots in the state. But this storm got locked in and just served as a chimney to pull in moisture and lift it into the atmosphere and generate incredible amounts of rain. So that's how we get the bulk of our summer rains, but usually in a much tamer form. Next, we get rains through tropical systems. This year, we've had impacts from about, you can stretch it, 8 or 9 systems have helped deliver moisture into the Garden State here with 29 systems record in the Atlantic Basin. 8 or 9 of them have had direct or indirect impacts on us this year, and frankly, kept us out of drought. Fay and Echiasis in the summer kept New Jersey wet for the most part. The Northwest got a little bit dry, but there was much more extreme drought in New England and even as close as central Pennsylvania and the Finger Lakes this summer. But those storms tracked over us and provided abundant enough rains to keep Jersey out of trouble this summer. But sometimes it's too much. And there we have Irene back in August 2011, and it was Floyd in 1999. And next shot will show you what an extensive rainfall it was for the state. The next slide is a compilation of rainfall data from a number of sources, and essentially everything in blue was 6 or more inches of rain, and the purples were 8 or more inches of rain. Mind you, the average August rainfall in Jersey is about 4.5 inches. This was the coup de grace in what proved by far to be the wettest month of any month back to 1895. And as I said, it would have been a 10th wettest month even without Irene. And Irene coming at the end of the month just really made it a remarkable, remarkable month for precipitation in New Jersey. The next slide shows you the third way we get our precipitation. And this is the season we're in right now. From mid to late fall through early to middle spring, we get mid-latitude low-pressure systems come through our region. When they track up the coast, we call them Noreasters. And it's where cold air and warm air clashes. You get moisture off the Atlantic or even sometimes from down as far as the Gulf. And it comes in and can really give us significant rain and or snow events. And there on the left, you can see what was a very snowy March of 2018. This was just one storm of several we had in North Jersey that month, where over 40 inches of snow accumulated at one location in the Highlands, which was a record for the month of March. So going on, so we've got those three systems. Now we've got our background of state climate. What about climate change, past, present, and future? Oh, I should mention that's those are the Poland's Kill, where the dam was removed. Beth Styler Barry talked about that yesterday, and you can see how the removal of the Columbia Dam has opened up the Poland's Kill. And full disclosure, I'm a proud trustee of the Nature Conservancy's Jersey chapter, so I had to make sure I got these photos into this presentation. Anyway, moving on. Thanks. Moving on. Cut to the chase. Climate change is happening. It's affecting us globally, and it's affecting New Jersey. Next. Why, you might ask? Well, humans are playing a major role. I have a high degree of responsibility for recent changes. So what do I mean by significant? The majority of change we're seeing. In some areas, the vast majority of the change we're seeing in terms of temperature, sea ice coverage, ocean warmth increasing, changing precipitation patterns. What's recent? The signal of human-induced climate change emerged from what is a admittedly very noisy climate system naturally, with highs and lows and wet and dry periods. But in the 70s to the 80s, the signal of human impact on the climate system began to emerge from that noisy climate, natural climate system. So we're talking the last 40 to 50 years or so. And how do we know this? There's theory of the greenhouse effect. There's observations that I'll show you a few for Jersey in a moment. And there are models where we model the climate system looking at the physics of the Earth atmosphere system, putting them on the world's fastest computers. It's our crystal ball. They are our eyes into the future. They tend to recreate the past well enough that we can use them to turn the dials by adding carbon dioxide and other greenhouse gases, for instance. And that's our look. That's our look into the future. So next, this just shows you some of the human factors that are influencing climate. Deforestation. Of course, New Jersey has been afforested in the last century or so compared to the past, but obviously globally there's been deforestation. Added smoke, aerosols, fine particles in the atmosphere, some that warm the atmosphere, some that actually cool the atmosphere. And there are natural ones from volcanic eruptions and natural forest fires, but we've added to that with agricultural practices and dust going into the atmosphere and smoke from human-induced fires. So that's one thing. And then, of course, greenhouse gases, carbon dioxide, methane. These gases increase in the atmosphere. They, in turn, help warm the atmosphere. That allows more water vapor, our most abundant greenhouse gas, to be more abundant in the atmosphere, and you get feedbacks that lead to warming and other aspects of climate change. The next figure, image, shows you, well, I should back off, just keep that slide, but just let me explain this greenhouse effect very simply. We have a natural greenhouse effect that keeps our planet habitable. We have natural gases in the atmosphere that serve as a blanket on our bed. When you're cold, you put a blanket on you. That keeps the heat of your body or the heat of the earth closer to the surface of the earth for a period of time. Now, eventually that heat leaves the top of the blanket. In this case, gets back out to space. Otherwise, we burst into flame in the middle of the night with the blanket on us. But if we're still cold, we put another blanket on. And what humans have done unintentionally is put another blanket on the planet. And with that, it's taking a longer period of time for the energy that comes in from the sun to leave back to space, thus adding that extra blanket and keeping us a little warmer. So it's just basic physics at work there. So that's the greenhouse effect. And what are some evidence of what humans have done? It's temperature. There's New Jersey temperatures, one of the faster warming parts of the nation. Temperatures over the last 125 years in this image here. Next, well, I guess the point here, I keep jumping back and forth. I'm sorry, Zach. The take-home point here is our coolest years in this century are as warm as our warmest years of earlier back in the 20th century. And we're hitting levels of temperature not observed in our periods of data gathering, again, going back to the late 19th century. But let's cut right to precipitation. And here it doesn't look as dramatic, but that's about a 7% increase in precipitation over the observational record. And I bring your attention to 2011 and 2018 over towards the right of that figure. 2011, thanks to Irene and Lee and a few other storms, was the wettest year on record until 2018 came along, which didn't have a major flooding storm, but just had persistent events of modest ranges and broke the record for 2011. And also note, in recent decades, the variability from year to year has become more pronounced than earlier in the record, although you can see the drought of the 1960s there towards the middle of the figure. But we're dealing with more variability from year to year in rainfall. So that's something you have to take into account. You just don't think of change necessarily as being a linear type of situation, up or down. You can increase the variability, and that's part of change. So moving on, this change has been manifest particularly in large events. What this figure from the National Climate Assessment just shows you that rainfall events of a 5-year return period over a daily precipitation or 2-day precipitation. On the left two figures, that's the full period of record from 1901 to 2016. On the right is from the late 50s to 2016. The take-home point is the northeast part of the United States has shown an increase, a large percentage increase in the number of these more notable extreme precipitation events. So moving on to the next. And this is manifest in discharge of our rivers. Now, here are 3 rivers just surrounding, originating within the highlands, surrounding the highlands. And what I did was look at the top 10 floods for each of these rivers. And then I just looked at them by decades and combined them. And what it shows you, there's greater propensity of top 10 flooding in the last couple of decades compared to the last half of the 20th century. Again, top 10 floods, all consolidated. So we're looking at 30 events here within the 3 basins. Some are the same event, but many are quite different. When the Delaware floods, the Raritan doesn't necessarily flood, or the Passaic flood, but they are notable flood events. So next. So that's the past. And we've talked present. What does the future hold? This is where we rely on these models, these sophisticated models. And they all suggest temperatures are going to keep rising. Even if we were to stop burning fossil fuels, the atmosphere would warm. And the fact is, 90% of the energy, the heat that's been produced by fossil fuels and has been held in the Earth atmosphere system is in the oceans. So even if we stopped with fossil fuel use, we'd have all that added warmth from the oceans to put out into the atmosphere. So temperatures are going to keep rising. I'll show you a map in a second showing you steady or perhaps even increasing precipitation in the northeastern US, keeping that pattern we've seen going. More energy in the atmosphere, more moisture in the atmosphere, warmer oceans, all suggest increasing extremes and variability in storms, flood, drought, heat. And you may say, oh, what a cop-out, Robinson, more floods and droughts? Well, yeah, think about it. If you have a warmer atmosphere with more moisture in it, and you can trigger put a trigger in that atmosphere to release that moisture as precipitation, you can get some increased rainfall events. But if that trigger's not there, you've got a hotter atmosphere that can dry things out and in turn create clear skies, which would dry things out further. So you can, unfortunately, have it both ways, both flood and drought. And then finally, to our coastal friends, looking at 1.5 feet sea level rise by mid-century, perhaps 2 to 3 feet by the end of the century. I was part of a report that came out of Rutgers, commissioned by DEP back in late part of last year, if you want to look far more about sea level and the future, its future along in New Jersey. So going on to the next slide. A couple of maps from latest national assessment, a few years old now, but the same models generally show this, have not changed. This shows everything in reds and oranges and yellows suggests that the middle part of this century is going to be warmer than the last 30 years of the 20th century. And I'll often kiddingly say everything in blue says it's going to be cooler. Obviously, no blue on here. Nationwide warming. The bottom 4 figures show it seasonally, and you'll note summer warming greater than other seasons. So warmer summers, and you see that over Jersey. Next figure shows you precipitation projections. The greens suggest things getting wetter, the browns drier. And yes, that means the southwestern US, which is already dry, getting drier. The northern plains, which are not nearly as wet as we are at this point, getting wetter, particularly notice in winter, and even over by us, wetter winters. But look at the summer, the lower left figure. It suggests that, first of all, the agricultural belt of the central US over to the East Coast, perhaps getting drier in the summer. So hotter, drier summers, milder, wetter winters. Next figure. That's the state of understanding now in general. But I love to throw this slide into a group discussion like this because you guys are really on top of things and are looking to how we can better understand this. We need to better understand the magnitude of the baseline change, just how much warmer. And the reason why I didn't give you numbers there, I could say 4 to 9 degrees Fahrenheit warmer. And you would say, wow, you're all over the place. It's not that the models differ that much. And there are a number of different global models. It's emission projections. Just how are humans going to control the emissions of these greenhouse gases or clean up the dust in our atmosphere? All of these things will dictate just how much warmer and how much more extreme our climate gets. And that's why you see these wide ranges, because some projections are business as usual. We're going to keep polluting away. Others have it more under control. And that's why you get the range. But suffice it to say, we need to learn more about this baseline change. We need to understand seasonality better. I've already suggested that we have to look at seasons in New Jersey because we could be facing short-term flash drought, if you will, conditions in the summer, and we're warm, mild, and wet in the winter. So how are we going to hold on to that moisture for a subsequently dry, hot summer? These are questions we're going to face and need to better understand, along with nature of magnitude of extremes. Are we going to see more extreme tropical storms or more numerous tropical storms or wetter tropical storms? Slower moving tropical storms? Are we going to see more nor'easters, fewer nor'easters? These are areas of active research right now. All signs point to things being more active, more extreme, and wetter. But we still have a long way to go to zero in on just all the faces of that change, if you will. And then, of course, the speed and magnitude of sea level rise. We have a much better handle on that today than we did 10, 20 years ago. Still a lot of work to be done there. So for any of you young folks listening to this, there's plenty for you to get on and get studying. So moving on, just in summing up, New Jersey has a wide and sometimes, it says, wild variety of weather and climate conditions. Change continues to our climate system in New Jersey, as it is elsewhere around the earth. And that does, we have to keep in mind, that includes extremes. And we have to also face the fact that change, it will continue, and it's likely to accelerate. And we're going to see more of these extremes. And certainly that's going to have an impact on the hydrologic system in our state. And those impacts are going to expand. And as I've suggested, it may manifest itself in periods of drought, but also enhanced periods of additional precipitation or extreme precipitation. And you know, I don't want to leave you without any hope. There's something we can do to deal with the magnitude and of these changes, mitigative actions. We can slow the pace at which these changes are occurring. And along the way, we need to, and we're already learning to adapt and become more resilient to these changes. But first, we have to understand them. We have to understand and all agree with what's happening. And then we can work even harder on mitigative and adaptive approaches. So I don't want to leave people hopeless. I like to say that we're smart enough to get ourselves into this predicament. Hopefully we're going to be smart enough to help to minimize the impacts of what we've done to our climate system. And with that, we got to keep an eye on things. And thank you for many of you listening to this are doing. And I can tell you here in the State Climate Office, we're going to keep our finger on the pulse of New Jersey's climate. Thanks very much.
All right. Thanks so much, Dave. That was fantastic. If anybody has any questions for Dave, I know we were going to try and wrap up around 12:15, but if you are amenable to answering a couple of questions, you were running a little over, but I think that was fantastic. And I'm sure folks have a lot to digest and hopefully ask questions. Certainly we don't all know it all. That's what you're here for.
Like I do.
You know a lot more than on climatology than I do, obviously. Yeah, I can riff on that forever. So yeah, if you have any questions, throw them over in the chat, and hopefully we have some time to answer as many questions as you can. Well, up to a point. It's Friday, right? We're all ready to go. I don't know about you.
I have 3 more meetings today.
Oh no! Yeah, everybody puts all the meetings on Fridays. I don't know what's up with that. Same thing here.
I should add that the last slide quickly showed my email, david.robinson@rutgers.edu, and I live for email.
Fantastic. And you also shared, I wrote down many websites that you shared, njweather.org, COCORAS.org, if you guys didn't catch those as well, and the Office of the New Jersey State Climatologist. Plenty of information out there, really fantastic information. So let's see, our first question, how does the United States hopefully rejoining the Paris Agreement help the climate change projections?
Well, it's certainly going to be useful to be part of an international consortium where everyone's hoping to get on the same page and meet goals set by the individual nations. They opened it up more to the nations rather than just one unified goal, because they thought that would be a more way to get individual nations to buy in and become engaged. It's so important that if you notice, and you blame it on Canada sometimes how cold we get in the winter, and you can blame it on the Caribbean sometimes for a Sandy, for instance, or right now we have a La Nina event going on in the tropical Pacific that's likely to affect our winter. The point is, everything is connected to everything. So this is a global issue. We can blame Pennsylvania, by the way, too, for thunderstorms that sometimes come in. But this is a global issue. So by joining forces, being back in that consortium, it is going to be a really important step in a very frustrating and long and ongoing process to try to get a grip and a handle and start better addressing this global issue.
Fantastic. Okay, so is it accurate to talk about global warming in quotes, or is climate change a better term?
I think you probably heard me say climate change throughout this talk. Global warming is a part of it, no question. But it's long been that. You look at my syllabi going back 30 years. I've taught courses in climate change. Climatologists have been accused of cooking up climate change when global warming wasn't as pronounced 10 years ago, for instance. We've been talking climate change throughout, and part of it's my cryospheric background. I've been studying Arctic sea ice and Antarctic sea ice and global snow cover on continents since I was a grad student. So I've looked at it far more than just a global warming issue. So that's my prejudices there, but it's far more than just temperatures getting warmer. It's global patterns of atmospheric circulation, of precipitation, of our ice and snow that are changing. So it's more than just temperature.
Okay. Any thoughts on the future of our groundwater dominated streams in New Jersey? Will changes in groundwater conditions simply reflect what you've been describing for surface conditions, or will they be decoupled?
That might be a little bit of our hope in some respects, although our aquifers drain so quickly in the rocky northern Jersey compared to the south. But remember, I mentioned that it's going to get wetter in the winters, perhaps, compared to summers. And that groundwater could be recharged in warmer winters where you don't have the ground frozen, for instance. And it could serve as an additional reservoir when our surface reservoirs, which have not been augmented since Mohonk Reservoir in the early to mid 80s, when they just fail us during a hot, dry summer. So I would think this wouldn't bode as poorly for groundwater resources in the state as it might for surface water resources.
What is the best way to manage spring snow melt in a year with a significant snowfall?
How to manage? Well, what you do is hope for a very well-behaved snow melt, which we had back in 2018. But we've seen other cases in January of 1996 where we lost 1.5 feet of snow in 12 hours in some parts of the state. You love to see a snowpack build up because you know it's going to help recharge our reservoirs. But in Jersey, we really, you have to realize, even in a snowy winter, even in North Jersey, less than half of the precipitation falls as snow. And more normally, it's 25% falls as snow in the winter. The rest is rain. So we don't rely on a snowpack in Jersey for our water resources nearly as much as Catskills, Adirondacks, and further north, and of course, out west. As much as I like snow, I get real nervous when I see 2, 3, 4 inches of water in the snowpack. Because I know how quickly it can warm up here and how quickly that can be followed by rain and pose a real major flood threat. So I'm not so worried about New Jersey potentially becoming more snow-free, something we haven't seen yet, by the way, than I would be in other parts of the country. Here, it's more a rain-fed system.
All right. Given the drier growing seasons that we face, what do you think the future of farming looks like in decades to come?
Well, we're gonna have to manage this with less water, using different, maybe growing different crops, managing irrigation, and irrigation is managed so much better than it was historically. But we may, that's where, so we're going to have to use management, farm management, when it comes to irrigation, when it comes to the crops that are planted, when they're planted, and so on and so forth. That's what I love about being state climatologist. I get my fingers around a little bit of everything, and I get to learn so much from the experts within those particular realms. So I've learned when to back off and say, okay, now I'm getting beyond what my knowledge base is. And that would be it when it comes to agriculture. We're here to work with folks from the agricultural community, give them a heads up on what's expected, and then learn so much about how their ideas are to address it.
So not hopeless, just adaptive management. I think that's fantastic.
Well, I might add also with Jersey, it's a matter of long-range weather prediction for a season, not just in the long term for our annual crops, as opposed to our fruit trees and such. And that is really tough. That's a lecture for another time. Long-range seasonal forecasting performs worse in New Jersey than just about any place else in the country. It's just difficult. We're squeezed in between the north, the south, the oceans to our east, and the land to our west. Very difficult to make seasonal projections in the mid-Atlantic.
Okay. You're going to have multiple different projections for all of those different locations, really.
Yeah.
And it confuses things for people, I guess. Maybe a little more to absorb there.
Yeah.
What do you think? What do you believe is the most important target or activity for reducing methane emissions, which is such a significant contributor to global warming?
Yeah, well, that comes to animal husbandry and perhaps changing our diets in this country, using less beef, for instance, who emit a significant amount of methane. There's also growing of rice, not so much in the U.S. I think they're doing a little more dryland rice cultivation down in Texas, but they still rely on a lot of water, and that practice produces a lot of methane. And then we have to turn our attention to polar regions, where there's a lot of methane in permanently frozen ground, and as that melts, there's a big concern that could be a runaway type of system. And then with some of the methane released through fracking and other ways of getting natural gas out of the ground. And we have to put better Band-Aids on that if we're going to be using that resource for the short term before we can replace it with a greener energy and stop it there.
I have just sort of an additional question on that regarding the permafrost. So I heard speculation that maybe that runaway might already have kind of started. Is there anything that what can we do to refreeze the permafrost that's already melted? Can we?
You can't do much to do that directly. But yeah, well, you can avoid it by making sure you keep the forest there, which could insulate the ground some. Keep your insulated ground cover there. Don't strip that away. But that's a real worry, and we're seeing more and more evidence. And we know the Arctic is warming faster than any place else on the planet. And with that, you're seeing permafrost disappearing, and it's huge. People may not realize, but it's a huge component of the land surfaces across the northern hemisphere.
Right.
Again, another discouraging thought.
Yeah. Let's see. Following up on the issue of dams, we are removing small dams, which are irrelevant for water supply, but huge ecosystem destroying dams might become in demand for water supply. Can water conservation practices be enough to hold off dam construction proposals?
Whoa, that's beyond my conjecture right here. I mean, you look at the Delaware Basin or the New York City water system, and that's 19th century damming and forming of lakes up there. Again, in New Jersey, it's hard to imagine another large reservoir being installed anywhere in this state. We just don't have the space or the resources to do that. So it's going to come down to better managing our water resources. And we've taken steps. Per capita consumption of water in New Jersey is lower now than it was before the drought of the early 80s, because we've taken conservation methods and industrial practices have diminished. but we have a very finite water. I mean, what I'm talking to the choir here, preaching to the choir. We all know we have finite water resources in New Jersey, and we can pull the plug on with a drought and drain them pretty darn quickly. And I'm not advocating deep drilling to the Cohansey Aquifer in South Jersey. Philadelphia tried that over a century ago, and they were stopped. And we don't want to start that. We have a vast ocean next to us, but it's incredibly expensive to desalinate in large quantities. But when push comes to shove, that might be a fix of some sort in the future. But again, a lot to think about. We have a lot of opportunities to explore these things. And as I said at the closing remarks, hopefully we're going to be smart enough to help, in a sense, engineer and societally manage our way out of more serious situations. And it's both ways. We're not going to just do it through engineering. We're not going to just do it through societal behavior. It's going to take all of that and more.
Absolutely. Okay, so one last question. Is it possible to have the atmosphere heated to the point that the water will not form clouds, which reflect the sunlight, and evaporate into space instead?
No, I have that. That's a great exam question for some of my grad students on the qualifying exams. No. I mean, it's shown closest Clapeyron relationship shows as you warm an atmosphere, it can hold, or there's more moisture that's part of the atmosphere. But it does raise the question with the warming and cloud formation and precipitation formation. It's very, very complex. But we're not going to take that water vapor and have it lost to space. It's rather relatively well confined within the Earth's hydrologic system. But where it all goes and how we manage it is the vexing problem we face in North Jersey and globally as we look to the future. Great closing question.
Excuse me, Dave, I'm not an interloper. I'm the Policy and Communications Director of the New Jersey Highlands Coalition. I'm going to be saying our goodbyes. Thank you very much. Thank you, Julie, for moderating. I'm sure for many people, this is the first time we've heard a presentation from you, Dave. I think we're going to hear a lot more from you. And we're really interested in hearing more about your deep knowledge of the water resources in this state. So thank you. And a lot of people deserve thanks for these 2 days. I want to thank our presenters and our facilitators. Zach, who has been really put this whole show together and then put out all the fires during it, along with Ronell from Hop-In. You've been a trooper, Ronell. We really appreciate it. I want to let everyone know that all of these presentations will be on our YouTube channel as soon as we can get them from Hop-In. And we have everybody's email address. Expect some more communications from us. And especially, we'd like to hear your thoughts about this conference. We'll be sending you a survey. We will have a third Northwest New Jersey Rivers Conference in the spring, whether it's virtual or it's live. We hope it can be live, but I can tell you a lot can be said for this virtual platform. It works quite well as long as we're a little patient with the, we'll always have some technical difficulties, but nothing that is a showstopper. So thank you everybody for joining us. And I also want to thank, she'll probably demur, our executive director, Julia Summers. She's probably one of the best boss in the world, and she keeps us doing our best at our best. So thank you everybody, and hopefully we'll see you in the spring.